Hello, we will be talking about the abstract factory design pattern. This presentation was created by Cordelia Wilson, Lucas Bittencourt, and Seth Bennett.
What is the abstract factory? As we can see from the list, the abstract factory performs the vital role of separating the two acts of using an interface and creating concrete objects. Each time you create an abstract factory, it will create a family of related objects. So you should only create a new abstract family when you want an entirely new family of related objects. This makes it relatively simple to switch out one abstract factory with another, making this design technique ideal for tasks like customizing user interfaces. This is because the client has access to the interface, but not the creation of the objects themselves. For example, if you have a program which can change its styles so it presents as a Windows program or a Macintosh program, the client is accessing the interface to switch out the Windows family of objects with the Macintosh family of objects, without changing the items themselves, like the scroll bar or how the windows look on the screen.
Abstract factory is a common design pattern, but we will still need to ensure that using it makes sense for the application and situation we find ourselves in. The most common use of the abstract factory is when an application has a lot of customizability. It would be impractical to leave an identical constructor in 5 different button classes scattered throughout your code. Any factory pattern would remove this repetition, but the abstract factory really shines when there are multiple related customizable widgets requiring multiple factory methods. The abstract class can organize various factories that create each type of widget, meaning updating and testing is as simple as removing an old factory and adding a new one to create the relevant objects. More generally, the abstract factory pattern can be used whenever creating an object and implementing that object can be separated. This is often desirable for a number of reasons. One is that it can increase the reusability of code that interacts with objects, making that code usable by multiple classes of objects. This separation also simplifies updating and testing code, so maintenance is quicker and simpler for both object implementation and object creation.
How would you use the abstract factory? Building an abstract factory does require a few extra steps to implement effectively. Rather than create your classes and concrete objects simultaneously, you can create an abstract interface which will delegate the creation of concrete objects. The client can only access the interface, not the creation itself. The first 3 steps focus on creating an abstract interface, which the client will activate in order to trigger the creation of concrete objects. As you can see from this diagram, it's important to carry out the steps in order, because each step of the abstract factory requires implementation from the interface before the concrete objects are created. The chain must be maintained. Note that the client only has direct access to the abstract factory and the abstract products objects. The concrete objects are handled behind the scenes. This is particularly useful when allowing a client to customize the look of a program without giving them the ability to directly change any key features. For example, if you wanted a program to depict a scroll bar as a rocket or an elevator, the client could choose between the two, but could not delete the scroll bar altogether.
So, some benefits of the abstract factory are: it avoids compile time implementation dependencies. So, instead of instantiating concrete classes directly, clients delegate the instantiation to a separate factory object. Also, it ensures creating consistent object families. When an application supports creating multiple families of related objects, it must be ensured that a family of related objects is created and used together. Also, it makes exchanging whole object families easy. Because a factory object encapsulates creating a complete family of objects, the whole family can be exchanged by exchanging the factory object. Although abstract factories can be very useful, it has its limitations. For example, it requires extending the factory interface to extend an object family. The factory interface must be extended to extend a family of objects in order to support new kinds of objects. This isn't easy because the abstract factory interface fixes the set of products that can be created. Also, it introduces an additional level of indirection. The pattern achieves flexibility by introducing an additional level of indirection, which makes clients dependent on a factory object. So, is the abstract factory pattern the best of all? Well, it actually depends on what you want to do. If you want to create a collection of related products that are designed to be used together, and you desire independence between creation, composition, and representation of products, and you want to hide implementations of the products, only revealing the required interface to provide access to their use, then if you want those things, I'd say you should use the abstract factory pattern. These were the references we used on our research. Thank you for watching our video, and I hope you've taken some good notes.